All right, so now what we're going to do is we're going to look at solving for actual time. So we're going to do, like I said, this is a longer video. That's the reason it's in 2 parts, because it would be even longer with the other one. All right, so when we solve for time, we're actually going to have to solve using some of our rules. So it says a person invested $420 in a rate growing at a rate allowing the money to double every 10 years. How long to the nearest tenth of a year would it take? So we know the initial amount. We know our P sub 0. We know our final amount. That's our A sub T or our Y, okay? And we know that it's going to double every 10 years. What they're asking us to solve for, they're asking us for time. So this is going to be a doubling problem. So we're going to plug in everything we know, and we're going to double our stuff based off of that. So we know that the future value is 960. We know the initial value was 420 times 2. And we know that it's going to take 10 years to double. So we don't know the time, but we know it takes 10 years. So we're going to have to solve for t. So we're going to have to use our logarithmic equations and solve this. So we're going to start by dividing by $420, or 420. So 960 divided by 420. Now, I would not use decimals here, because you could essentially throw your whole answer off. I would continue to do exact values as much as possible. And then I have 2 raised to 10t. And this is where I would convert. So I don't have a logarithm. So I'm going to say 2 raised to 16 over 7 and convert this into a logarithm. So log base 2, and then I have 16 over 7 equals t divided by 10. And then the last thing you would do is multiply the whole problem by 10. All right, so now we're going to put it all in the calculator at the final step to ensure that we have the exact answer. 16 over 7. And we get that time was 11 point, and it says to the nearest tenth of a year, so 11.9 years. It took 11.9 years. Now, how can I test this answer? So, if you were in class with me when I taught this, then I showed them that I can split this up into 2 equations. I can split my left and my right up. So if I do y equals the left side, which is 960, and y equals the right side, so that's going to be 2 raised to, and you can't use t, so you're going to have to use x. You can actually find the intersection here. So you're going to have to keep scrolling out until you find the intersection. And that intersection, the answer is the x value, which we can see we got 11.9. So you're basically going to create a system of equations, the left side equal to the right side, and solve. Okay? All right, so a new car is purchased for $20,000. The value of the car depreciates, so we're going to depreciate. All right, so that means we're going to decay at 11% per year. So to the nearest tenth of a year, how long will it take it to get to that value? So we have our initial value. We have our future value, and we have our percentage. We're going to use a basic decay problem here because there was no other key phrase that told us otherwise. All right, so we're going to plug in what we know. So we have my future value is going to be 5,700. We know that we started with 20,000. We have 1 minus 0.11 because that is going to be converted into a decimal raised to t. All right, so we got to get that base by itself. So we're going to divide by 20,000. And again, I'm going to keep my exact value here. And I want to make sure that I have an exact answer at the end. And I can go ahead and subtract 1 minus 0.11. And that gives me 0.89 raised to t. And now I can convert it. So I start with my base, raise it to 57 over 200, raised to t, or is equal to t, excuse me. So I have log of 0.89, and then I have it raised to 57 over 200 equals t. And I can plug it right into Desmos. All right, so t is approximately, and it said round it to the nearest tenth of a year, so 10.8 years. All right, again, I can test that and make sure I have the right answer. That does not mean that you get out of having to actually solve it, showing your work. So I have my left side equals 5,700, and my right side is going to be 20,000 times 1 minus 0.8 or 0.11. And again, you can't do t, so you're going to do x. Now, my initial value is 5,700 that I started with. So I'm going to really have to zoom up there and find that intersection. And again, you can test that and find the answer. All right, so the next one, I started with 54,000. I have 4% compounded continuously, so keyword here is continuously. So that means I'm going to use my continuous formula. You have K or R, whichever one you prefer. Now, we have our initial amount is 54,000 at a rate of 4%. It is growing, okay, because they're investing, so this is going to be a positive growth. And we're going to change that amount, so we're solving for t. So I have 106,200, 54,000, e raised to, that's going to be 0.04 t. Now, since we're doing continuous, I would definitely use a natural logarithm here. But we're going to solve for e first. And again, keep your exact values. Do not round until the very end. All right, so when we simplify that, I got 59 over 30. If you don't want to simplify, that's fine. You're just going to have to write more numbers. So at this point, instead of converting to log e, I would take the ln of both sides. Because remember, when I do the ln of both sides, that inequality rule says that those are going to cancel. So I'm now left with the natural logarithm of 59 over 30 equals 0.04 t. And I can just divide by 0.04. So I'm going to go put that in. So 59 divided by 30. And then that whole thing is divided by 0.04. So my time is approximately, it said round to the nearest year, so we're going to go up to 17 years that it took to get to that value. Once again, I can test it in Desmos, take the original equation, so y equals 106,200, y equals 54,000, E I'm going to find in the keyboard, raised to 0.04, and X. Now, this one is extremely big, so I can sit here and scroll out till I reach that value, which, I mean, you can do it pretty quickly. But what you're going to have to do is once you find the intersection, you're going to have to keep scrolling back in until you can find it. Why do you have to do that? Because when you click here, you may be clicking that y-intercept. You really need to zoom in and get a good, distinct intersection. And we got 16.9, which we rounded to 17 years. All right, so doing this, I'm going to do it one more time. This last one is a half-life. I can show you how to set it up, but you should be able to solve it the exact same way. So it says Joseph invested $89,000 at 6.6% compounded quarterly. So we're going to use our compounded formula. Remember, our compounded formula has our n's in it. So if it's quarterly, then n equals 4. So my value that I'm going to is 237,600. I started with 89,000. And then I have 1 plus my rate is going to be 0.066 divided by my compound of 4, and then 4 times t. Okay? Now, when you're doing this, it's the same process, but the key here is that this whole inside is going to be one whole number. So it's going to be a lot. Now, you can go ahead and try to calculate that, but more than not, you normally can't turn it into a fraction. Now, this one you can. Great. So we can turn that into a fraction. I'm going to go ahead and divide by 89,000. So these are not going to be nice, pretty numbers and fractions. You're really going to have to be careful when you're doing this. All right, so this one's 1188 divided by 44.5. And then we determined that this whole section right here was 2033 over 2000 raised to 4t. All right, so now I can convert it. So remember, my base raised to my equal to equals my exponent. So I'm going to have log of 2033 over 20,000 raised to 1188 445, and it's going to equal 4t. All right, so I got a lot going on here. Let me kind of separate this. Actually, let me just go on and use some different colors. And that last thing is going to be divided by 4. So you're really going to have to be careful when you put this into Desmos. So I'm going to go ahead and start with my fraction. All right, so I'm going to start with the numerator. So I have log and in parentheses. All right, so I have 2033 divided by, whoops. Okay, so it's not going to work with us very well. So it seems that we are not going to be able to put, even with parentheses, put the fraction in there. So you're going to have to do that change of base formula. So remember, the change of base formula says that I would do the log of the top part, okay, divided by the log of the bottom part, which is going to be 2033. And then the whole thing is going to have to be divided by 4. So I'm going to do the log of 1188 divided by 445 divided by the log of 2033 divided by 2000. And then I'm going to take that whole thing, okay, so I'm going to put parentheses around that and divide that whole thing by 4. So my time that it took to get to that value was 15 tenth of a year, so 15.0 years. Okay. Now, again, this is the same process with the next one. You would set it up. You would do a half-life this time, though. So we're going to 24 grams. My initial value is 18, and I have a half-life. And here's the deal. The half-life takes 18 years, and they want us to calculate. Oh, I plugged that in wrong. So the initial value is 40, and they want us to calculate 18 years for the half-life. So you would be solving for the time there. Okay. All right. If you have any questions, please don't hesitate to ask me.